All right, make sure you put your initials for this week. Last week there wasn't any class, so I'm not sure what these are about. So make sure you put your initials on the 27th, not the 22nd. I should have graded out or something. And then I just added at the very end the comp class, I think. Yeah, an extra class here on the 17th. All righty. Share coordinates, beautiful share coordinates. And so you guys see my screen? Yes, you can just let me know on the chat panel. I think I'm sharing the right thing. Yeah. All right, so I talked about this a little bit earlier in the course, but we're going to go a little bit in more detail. One thing we need to make sure is that we understand that Revit is not an infinite space, that the maximum size of a project we can have is something around 20 miles in every direction. And this is related to the fact that there is a limitation at which the internal calculation of Revit start failing. If a file is bigger than 20 miles, you will get a warning that the file is too big. And the calculations around visualization and view refresh will not complete inside Revit. And then you may start experiencing strange behaviors, for example, elevations that don't appear, or sections that have crop regions or crop areas that are not rendering correctly, or you send something to print and it's coming out cropped without explanation. So those are symptoms that there is a CAD file or elements in the Revit file that are outside of the maximum 20-mile space. If you bring an element in Revit that is bigger than 20 miles, you will receive a message like the one you see in the screen here. It's a warning that says that geometry is larger than 20 miles. And as you can see, it will result on undesirable graphic behaviors. If this thing pops up, try not to avoid it. Because you can, if you click OK, you will continue working on it. But then eventually it might start creating problems in the software, in the project. So the best way to fix this is to go back, open the DWG, and make sure that it's bounded within a compact area and it doesn't have floating elements in outer space. All right, and within the coordinate system, we have 3 points that are part of the coordinate system. And this is what makes Revit a little bit confusing, because in AutoCAD, things are pretty straightforward. There's only one origin, 0, 0. And then, and that's it. You send that email and there's no question about where the origin is at. But in Revit, we have 2 points that are that we need to understand and that impact how we coordinate a shared location. First, we have something that's called the internal origin. Internal origin is also called the startup point. And it's defined like the center of this 20-mile space radius. In the past, this point used to be invisible to the eye, but starting in Revit 2019, they disclose it. It's now a visible point. It looks like a gizmo in 3D. But it's a point that doesn't report coordinates, and it's not selectable, and it's not modifiable. It's just sitting there in the middle of the 20-mile space. Um, internal origin, it's important because it allows us to export. It's one of the options that allows us to export a Revit file into an AutoCAD file. When you export to DWG, you are given an option to export using the internal origin. And it's also important when we link or import other Revit files using the internal origin to internal origin. And what that means is that we have two files, and the center of the 20-mile space of one file will be at the center mile of the 20-mile space. And you will see. Now, internal origin is probably, if you can start everyone modeling using the internal origin, that's probably the easy thing to do. But sometimes, and it often happens that multiple consultants start modeling in their own design options at a point where internal coordinates haven't been established, let's say in pre-design. And then when all these models come together, they're not aligning. And so there is an alternate way in which we can make these models line up. And that is using these other 2 points. One is the survey point, and another is the project base point. The survey point, it's Revit shared coordinates, and it's the project 000. But unlike the AutoCAD origin, the survey point is a relative point. It could be sitting anywhere in the XYZ space, bounded between the 20-mile space. And it reports coordinates using survey units. So that means it's north, south, east, west system. It's a quadrant type of coordinates. So if it's positive, it's going to be in the north side. If it's negative, in the south side. East, west, the same thing. And because this point is relative in every model has every model in the federated collection of projects. They may have different coordinate systems. And so that's why it's important that we understand how to establish shared coordinates. And I'll show that in a second. The other point is this one called project base point. It has the shape of this circle with an X. Forget about this clip. This was an old behavior, and starting in Revit 2020, the project base point no longer have this clip. And this is the project base point is also called a building work point, and it indicates a point that is discipline specific, that usually is aligned with the start point of the project layout. For the most part, the project base point is it's placed at the intersection of two grid lines. Usually the lower left side or the upper right side, and the other value of the project base point is that indicates an alternate level elevation. And so if you remember, when we created levels, we have the ability to report elevation relative to the survey point. Survey points are usually placed at sea level, or we can indicate the levels to report elevation based on the project base point, which is at the ground level. And therefore, the relative height will be relative to the ground level. And so the inside of the project, by default, when you start a new project, both project north and true north are aligned in the same direction. They are pointing up on the screen. And you know the difference between project north and true north. Project north is the orientation we give to our floor plates so that they appear orthogonal in our sheets. And it allows us to represent our buildings in an orthogonal manner. And then the true north is the orientation associated with the geodesical location of the sun, and is usually aligned with the North Pole. And the declination between true north and project north is an information we will find typically in our surveys or information that civils should provide to us. And when we start a project, both project north and true north are aligned. But then when we get the information of declination between project north and true north is something that we can customize and we can add to the project base point information. If you notice, the project base point is the point that collect information about the orientation with the true north. Okay, and so when there is a declination angle between these two orientations, you're going to see that the cube box actually rotates and it's no longer aligned with the main geodesical orientations. All right, so let me quickly show how to find this. No, let's continue this. One thing, I'm going to skip this slide because it's not all information. The process of establishing shared coordinates is something that needs to be documented as a project in the project execution plan. And it's usually a process led by the BIM lead in a production organization. So if you're a sub-consultant of another firm, then typically you would receive this information in a written form. If no one is providing you information, you are entitled to ask your BIM lead what is the location of the shared coordinate system and what is the process you should follow. You should not come with your own process, because then chances are that we might affect the way in which these models are aligned. But if you are the BIM lead in organization, then this is the typical process. The architect or the civil or the landscape architect, whoever, there needs to be an owner of a model that determines the shared coordinate system. And this project owner will work with the civil survey to identify a point in the survey that is associated with a monument. And you've seen these typical monuments in the cities. They are usually these metal plates sitting at the sidewalks or straight intersections that are registered with the state of California. If you're working in California, if you walk down San Francisco, you find them everywhere. And those points are usually monuments that are used by the civil surveyor to anchor the survey elevations of existing conditions. One of the first conversations that needs to happen is identify in the site relative good location of a shared coordinate system. Then we work on a model that determine the shared coordinate system. Typically, it's a site model, or sometimes it's the same architectural model. And then we overlay the survey, and we move this relative point, the survey point. We snap it to the location of the monument in the survey. When this is established in one model, we call this model the source file, because this is the file that contains the correct location of the survey point. This site model, it's shared to all the subconsultants, and it's linked into each and every discipline model. The model linked needs to be rotated and aligned to properly align with your consultant work. But what we're not going to do is to move the Revit elements. We always move the link so that it matches the location of your project. And once we establish the proper alignment, the proper rotation, the proper elevation, then we enable shared coordinates. The shared coordinates is the process of acquiring the coordinates of a project point, a project survey point. And there are two methods of the way it works is that you select the link and enable shared coordinates in the instance properties. And you're presented with two methods of enabling coordinates. One method is to push the shared coordinate of your model into the link, but that's not the preferred method, because you're technically editing a sub-consultant file, and you don't want to be the person responsible for that. And I think the preferred method is that you link this site model or the source file, and then acquire the shared coordinates from the model, from the link model into your own model. And this is a one-time operation. And once this shared coordinates are established, they're going to try to maintain an alignment between them moving forward. And this alignment is going to remain alive for the rest of the life of the model. All right, so typically BIM managers are in charge of doing this because this is a one-time operation in the life of a project. Sometimes there's a need to fix them shared coordinates. It's a little tedious, but hopefully you get how it works and you'll be able to do it yourself. All right, let's do an exercise in which we will establish shared coordinates between a civil DWG file and the architectural, structural, and mechanical model. So on the chat panel, I left a link to the data sets. Hopefully you have downloaded that. Let me know if you have not. But you can download, unzip the file, and place it in a folder location that is of easy access. So launch Revit 2021. And we are going to start a new model from scratch. New model from scratch. And I'm going to use the architectural template. And then we create a new project. So the internal point, project base point, and survey points are all part of that, or all of them are subcategories of the site category. And they are visible under the site view in the project browser. So if you open the site view, you are going to see that you have the project base point and the survey point on top of each other. In fact, if you click on top of the project base point, you can drag it out and notice how the project base point is reporting units or distances relative to a 0, 0. The survey point is always going to be the project 0, 0. And the project base point will report distances relative to the location of the project base point. You can just select the project base point and and see how the coordinates change. You can change the coordinate of the project base point by clicking on the coordinates themselves on the screen. You can also change it in the instance parameters. To return this back to the start location, you can just change this to 0, 0. When you change this to 0, 0, it's always going to try to move it where the project survey is. This is the survey point. And the survey point, it's always going to be 0, 0. This is a relative point as well. Remember, this point can move across the XYZ space of a project. And no matter where you move it, it's always going to be 0, 0, 0. And the project base point is always going to report coordinates relative to the location of the project base point. But the project base point has something that is called the startup. When you right-click on the project base point, you're going to see an option that says move the project base point to the internal origin. And this is just a way to make it align with the origin. I can move it and snap it. And now I'm taken back to where it was before. All right, so there is and I was telling you that started in Revit 2020. They disclosed the point interior, the interior point. And if you open visibility graphic VG and go to the site category, you're going to see that this is a new row called internal origin. Click that checkbox, and that's going to disclose that gizmo. The gizmo is it's a coordinate system in 3 arrows, and it's just for reference only. I'm going to move this away, and notice that this is the origin. The origin has a visual representation, but cannot be selected at all. It's just a visual representation. Then you have the survey point, which is the Revit 000. And then you have the project base point, which is a relative point reporting units of the survey point. So to align them all again together, you can just right-click on the project base point. Escape. Right-click on the project base point and move to internal origin. And what this is going to do is going to move the project base point back to the internal origin. And to move the survey point with the on top of the origin, just move it, and you're going to feel like it snaps. And I have my 3 points aligned on top of each other. So here, this is the easy way of aligning elements, and this, but more often than not, this does not happen. You just bring a CAD file, snap it to the location of these 3 points, save it, and then send that file to the rest of the consultants and say, hey, this is the origin. We're all going to start in this point, and use this as a reference to where the point is located at. And no need to go into this whole discussion on how to align them afterward. But different consultants come into place in different times, and sometimes consultants develop their models based on as-builts that use a different coordinate system, or sometimes you receive models from other firms that are also using a different set of coordinate systems. And so there is some, at the start of a project, there is a need sometimes to alleviate where the coordinate systems live. And that's why we need to use this more complex process of coordinating shared coordinates. All right, so let me explain you what we're going to do. We have, I put my models in my D drive, and in here I have a civil drawing that it's a survey of existing elevations. And then I have architectural, MEP, and a structural model. And all of them are in different elevations and different points. And we're going to make them align. So we are going to save this file. I mean, this file I just created. Make sure that all the points are aligned. I'm going to save this file as, and this is going to be the source file. So I'm just going to call this site coordinates. And the purpose of this file is only to capture the location of the shared coordinates file. All right, I have a new file. And now I am going to bring a CAD file. So in the list of files that I sent you, there was a civil site. So we're going to import it. Or you can link it. Or for this exercise, I'm going to import it. Importing is not a good idea, especially when it comes to civil drawings, because they are usually famously complex and with a lot of floating elements outside the project region. So what we're going to do is we're going to insert, and the reason I'm doing this in a separate file is because I don't want to mess the architectural documents with some file that could be as dangerous as this civil drawing. If I mess anything, I mess it in this site file, and I'm not compromising the integrity of the documentation of the architectural model. And so go to the insert file here, and then import CAD. And in the CAD format, look for under the datasets folder, this site civil. And when you import this, you have these different choices. The colors, it's how the CAD file is going to translate into Revit. You can preserve the color by layer. You can invert the color so that it looks better in a white background. But for the most part, people like to display the civil drawing in a black and white. So Revit is going to switch off all the AutoCAD colors and make them black and white. Here you have the option of bring all the layers or only the things that are visible, things in the AutoCAD file that are thawed and that are turned on. I'm just give it all here. Import unit auto detect all usually works well. I'm just going to leave it as is, auto detect. And then because this is the first time I'm working with a CAD file and with I'm going to do these center to center. And then I'm going to place at level 1. And then I'm going to orient to the view. These two checkboxes I usually switch off. I don't want AutoCAD to correct things like a easement line, for example. That is super, that's a big liability for production. And Revit likes to align things that are not perfectly orthogonal. And so avoid those potential mistakes by clearing these two checkboxes. And orient to view aligns the orientation of the CAD file with the orientation of the view. And this may not be what I need. And I'm going to place it on level 1 and then hit open. So when I zoom extend here, I'm just typing ZE here. Here's the CAD file. It's right now visible on the side view. And let's save this. Let's save this file as site coordinates. And what this is showing, it's a road. This is the footprint of a building. This is the true north orientation. And in the DWG, I have a reference for the main grid lines. Because one thing I need to do is make sure that the models have a way to snap and align to monuments in the CAD file. And that's why it's important to have at least the proposed footprint of the building in the survey file. If you are the person defining that survey, then you have to do that work in conjunction or in coordination with the civil person. Okay, so the other thing you wanna do is understand the ground elevation of this drawing. And so this civil drawing, I believe it's in 3D. And so all these different elevation markers, I believe they are 1 foot apart. I believe you can find the elevation of an object just by clicking on the spot coordinates. I believe, no, annotate spot elevation, I think. Oh, never mind. This is not. But so I'm going to switch to AutoCAD here, and you may not need to do this, but I'm just going to open AutoCAD to understand the elevation of these survey. And so when I look at the properties of these elements, notice how in the property window, I see a property called elevation. So this is 64 feet. And then this one is 58. And then this one is 56. So I have 56, 58. Then I have 64, 66. So these are 2 foot apart. I'm probably missing one here. I don't know what happened to that. But these appear to be 2 feet, 2 feet apart. And so I am going to assume that the ground level of this footprint it's 60 feet above sea level. And this is something you can quickly figure it out if you have the right information, or maybe you already have information about the finished floor. But 60 feet is the ground level. So I'm going to switch to the south elevation in this view, and then I'm going to do 2 things. There are some existing levels here that I need to rename. Level 1 on the south elevation, I'm going to rename it as group sea level, and sea level is always going to be 0. And when you get this rename warning, you just say yes. And then level 2, it's going to change the name as well. I'm going to name this as top of ground level. And you want to rename it. And I know because I explored the AutoCAD file that this is going to be 60 foot above sea level. And now that I have these 2 levels up, and I'm going to just stretch them towards the project location. Again, and I'm going to do the same on the west elevation. If you switch to the west elevation, select the levels, and you see that at the end of the level, you have this white grip. Just click at the center of the white grip and stretch it. Keep press and pan over to the left. And this is so that the levels have an extent across the entire site. All right, so I have my sea level, I have my top of the ground level, and then I'm going to switch to the 3D view here. This is how the site's looking. I'm going to switch back to the site level, and then here comes an important discussion. You have to talk with the civil or the survey person about what is a point in the site that should be the shared coordinates for all the models. And the shared coordinates could be the center of these rotunda, or it could be any corner of the coordinate of the survey lines. For my purpose, I think we're going to agree that there's a monument here, there's probably a tree there, and we're going to choose this point as the shared coordinate for everyone. And so what I need to do now is to select the survey point, and you can just hover over and hit tab. I'm just hitting tab to cycle between the survey point and the project base point. Again, just hover over the point. Notice that the first thing it pre-select is the project base point. If I hit tab, okay, enable this, hover over and hit tab, then that it's the survey point. I'm going to move the survey point. Make sure it's the survey point, not the project base point. I'm going to move the survey point all the way to the corner of at the upper right side of the coordinate system of the perimeter. So this property line corner, it's what we identify to be the project survey point. You can pick another one. It really it's a relative point, but it needs to be at the ground level. So the coordinate and elevation is always going to be 0. And then you have the northwest, east, west coordinate as 0, and I snap it to this point location. All right, then the other thing I'm going to do is to align the project base point to the coordinate of A and 1. And so one thing you want to do here is select the project base point and just move it out. Move it near the intersection of A and 1. And then I'm going to use the move command to be very precise. So the move command will ask me for a handle in the point, and then I'm going to snap it to the green intersection. So select the point, hit the move command. The first point is the center of the point. And the second point is the intersection of A and 1. And if you want to pick the intersection, just type on the fly SI. And it's going to pick exactly the intersection of A and 1. And that is the project base point location. All right, so hopefully you're with me here. Let me know if you need me to go over in the chat panel of anything. So now I have the internal point is left behind. Then we have these project base point location here, and then we have the survey point here. And then the last thing I'm going to do is to establish the angle between true north and project north. And so that is an angle I need to discover. And the best way to do this is using just a reference plane and measure the distance between the reference plane and the orthogonal line. So I'm going to create a reference plane, which is architectural tab, reference plane. And from the project base point, I create this reference plane. And then I also create an angle, or find the angular dimension between the true north and the project north. And it just happened to be 11.19. And so if we want to be very precise, and I sometimes recommend you to do this, I mean, point of an inch, point of a degree, it might not be a big deal on small projects, but when it comes to big campuses, it does make a difference. So I would recommend us to change our units to the maximum allowable units, and use that as a angle of rotation. So you go to the Manage tab, and then go to the project units, and open the angle units. And right now it has 2 decimals. I'm going to switch to custom. I'm going to add 8 zeros here. 1, 2, 3, 4, 5, 6, 7, 8. And that's enough of rounding, right? So you just go to angle here, change this to custom, and then add 8 zeros for the rounding increments. And then I have all these decimals available to me. You can actually copy these values very easily. If you select the reference plane, notice how the angle becomes into a temporary dimension. And then you hit on top of the angle, and then you right click. You can copy the distance to the clipboard, because I'm going to use this. I'm going to use this as the angle of declination between the project north and the true north. And by having all these extra digits, I'm making sure that I'm very, very, very precise. I'm going to copy this to the clipboard. Again, if you fall behind, all I did is create a reference plane, architectural reference plane, from the project base point towards the north. And then I created an angle dimensional angular between these 2 references. And then I changed the units by going into the Manage tab, project units, hit the angle format, and add 8 additional digits next to the point in the rounding. Custom 8. All right, so I'm going to select the reference plane, select the angle distance, and then copy to the clipboard. So under the Manage tab, project units, you probably see them as a singular icon. My user interface is Crunch because I have a low resolution in order to broadcast, but it should be under Manage. The icon, it's 00 with a little, like a little calculator, and it should be under the settings panel, Manage settings. Yeah, got it. All right, so then you go into the angle format and change the rounding to custom and add 8 more zeros there. Precision is everything when it comes to site. And I've been involved in projects where there are lawsuits because somebody moved or didn't put attention in keeping the right easements. Okay, so after doing that, we selected the dimension and select the reference plane. This is you're going to see the dimension in blue. That means it's a temporary dimension. Click on the value, right click, and copy to the clipboard. Or if you prefer, just write this down in a piece of paper, and then we're going to type it down again. All right, so we copy this angle, and then we are going to now define the distance between the project north and the true north. Any question here? And I see you, Zina.
Yeah, hi.
Sorry, you'll have to catch up later because we.
Yes. Yes.
But the recording is going to be there for you.
Thank you.
All right, so under the Manage tab as well, there is a project location panel. And in the project location, you will find a set of tools that deal directly with coordinates. Right here, there is a button called Position. And again, my icons are stacked because I have a lower resolution. But on your end, you probably have them this side by side. So under the Manage tab, find the rotate true north. Sorry, no, not true north. Rotate project north. Because that's what we're going to do. We're going to, right now, the project north is looking up. What we want now is to rotate project north. Oh, but you know what? No, there's an easy way to do that. In order to change the distance between project north and true north, switch this side view to this orientation. In the orientation here, you're going to find that everything right now, it says project north. I'm going to switch this to true north and apply it. Nothing happens, but all I'm making sure is that the active view, the side view, is correctly associated with the true north. And so when I open the side view, this is what I'm finding. I will be finding the true north orientation. And so to change the project north, or the project north, yes, select the project point, and you see it says angle to true north. And in here, I'm going to paste the value that I just created, that I copy from and apply it. Now, the problem here, I think, is that angles are measured from the east. That's how Revit is set up. So I'm gonna do this, and I think I need to do 180. I need to do 100. If the angle that I measure here is gonna be 90 minus 11 minus this. Let's try that. So again, in the project base point, I selected, I think I'm going to do 90 minus the angle. Oh, it doesn't have to do it. Or I could just, oh, there you go, Amit. You're right. I can just do minus 11, and there you go. That was easy. Or it was 360 minus 11. Or you can just do minus 11, and that will work. Thanks, Amit. So your angle, just type minus and then paste the value and then apply it. And this is the equivalent of 360 minus 11.18, and that's exactly the same thing. Revit likes the angle of true north is never going to be reported as a negative value. So what I usually do, I duplicate this view, and I say, and I rename them. One view, I'm going to call it true north, and this is a reference for everyone, true north. And then I'm going to do another one that is going to be project north. Project north. And so project north is going to remain associated true north will be associated with the true north, with the project north, sorry. And project north, it will be associated with the true north. And now I have the two different orientations. You can actually swap them. You can switch between project north, but that's not what I wanted. True north should be actually the opposite. This should be project north, not project. This should be true north. Yeah, I'm not happy with this because it's not, the orientation is not working as I intended. So, okay, so let me undo what I just did. Sorry, I have to undo all the way to the to before the place dimension. Yeah, so I undid until it says place dimensions. All right, so I'm going to use the method I had started. So I have two reference plane, one that indicates the true north and another one that indicates this the project north. And so under the architectural tab, I'm going to go to reference plane, and I'm going to use the pick line tool to pick the grid line number 1. So I have two reference plane, and in fact, you can select this reference plane and rename them. I'm going to rename this as true north. Actually, this is project north. Sorry, project north. No, true north. True north. And then this other reference plane that I just created, this is going to be the project north. The angle is still the same. But what I'm going to do now is to go to the Manage tab, and in the position, there's a command called Rotate Project North. And then one of the options is align the project north to a selected line or plane. So I'm going to scroll all the way to the very bottom where it says align selected to line. And I'm going to pick the project north location. So, let me escape again and explain again. So far, what I did is I undid a bunch of commands until I created the dimension. Then I created a reference plane. You go to architectural reference plane and create this reference plane. Then create another one that is using the pick line tool, and I click on the number 1 grid, and then I find the angle between them. So you go annotate angle between these two reference plane, and it should be exactly the same thing. So in the project, I'm in the side view. The side view, make sure you you establish this to be the true north, because this is what the true north needs to look like. And then and this is important, make sure the true north is aligned with the view first, and then execute the command. And then go to the Manage tab, site location, and then I need to duplicate the view. Sorry, I need to duplicate the view and call this view Project North. Project North. This is exactly the same thing. And the one below, I'm just going to call this True North. So the True North view is associated with True North, and the Project North is associated with the Project North. Okay, so I have True North in one view, I have the Project North in another view. Right now, they are exactly the same thing. Under the Project North view, then I go into the location and then rotate Project North, pick an align select plane. And it says that Project North has processed 106 elements. These elements are mostly the views, and then hit OK. So I have now Project North, which is aligned with the building, and I have True North, which is aligned with the True North orientation. That makes sense? All right, so I'm going to save this. And I know that maybe some of you fall behind. So I'm going to make a copy of this file and post it in the drive and share it to you guys. So let me do that very quickly, because the rest of the exercise is based on this file. And if you don't have this file, then it's going to be difficult. So I'm going to go to my summer share coordinates, site coordinates. Here is, I'm going to copy this and then I'll upload this into the drive. Okay, so these site coordinates, I'm just going to drag it and drop it onto the share coordinates folder. And I'm going to share a link. Copy link. And if you fall behind, just download here. It's on the chat panel. And you should have my file. All right, so there are three important things that this file has. It has the correct location of the survey point. It has the correct location on the project base point. And it also has the right angle between project north and true north. And so then I'm going to save this file. And you know, one thing that I could do also very quickly is to create a topo surface. So make sure you download that file. Because one thing you may want to show in your project is how the model connects to the ground. And because I have these elevations in 3D, I can very easily create a topo surface using the existing elevations. All right, so hopefully you have that file that I share. And to move forward, just open the file, and then we're going to create a topo surface. I need to investigate what is the layer that the elevations are living. So when you select a CAD file in 3D, you will be presented with this import instance options, where you can query and find what the layer is. So there is a layer here called C Topo Minor. And there's another one called C Topo Major. And I believe those are the layers I'm going to need to create the site. So with that information in the back of my mind, I can create a topo surface. Topo surfaces are representation of a surface of a site. You can build them under the massing and site under the topo surface tool. So massing and site, topo surface. And there are two methods of creating topo surface. One is by placing points. We're not going to do that. It's going to be too tedious. And another method is to create an import, to create one based on an import. So I'm going to do this. I'm going to create it from import. And I'm going to select an import instance and select the link file. And only select the layers in the CAD file that contain information about the topo elevations. And I know that those are the topo major and the topo minor. Those are the two layers that have information about elevation. So hit OK here, and then hit the green checkbox. And now I have a site. And this site, you know, has the right elevations. I can always use it as the background for my project. Does that make sense? Again, to repeat the process very quickly, all I did is go to the massing and site, topo surface, create from import, select import instance. This is an option in dropdown. Select the CAD file, clear all the checkbox in the layers, and just select the topo major and minor. And then hit the green checkbox. Don't forget to check the green checkbox. And now I have a project site. And then the other thing I'm going to do, if I switch this to the true north, is to create a pad. And a pad is going to represent the top of the finish ground level. And I can do that very quickly by switching to the true north and then switching to the wireframe, which allow me to see through the surface. And this is the shape of the pad. And remember, we said that this pad was going to be at elevation. I think I said 620. I think. What was that? One way to find out is we can label these contours in a floor plan. So if you go to massing and site and create label contours, it will you can choose 2 points, and we will disclose for you what is the elevation of each. And I think we said this elevation was going to be 64 throughout. So this line. Okay, so to create the pad, you go to the massing and sites, and then hit building pad. And again, I just need to pick and choose the boundaries of the footprint. So you can either retrace them. I'm going to use the pick line tool. So just hover over the edge of the footprint and hit tab. And that's going to select all the lines for you in a single click. And make sure the elevation is 64. So from sea level, 64 foot above, that is the pad elevation. Or you can do it to the ground level and make it 0. Because I know that this is going to fall. This is probably better if you go to the ground level and just change height elevation from level 0. Then hit the green checkbox. When you switch to a 3D view, there is the pad, a flat pad running through the 3D site. Okay, you guys with me? All right, so I'm going to save this. This is my site, and again, it has the true north south, the true north and project north orientation. It has the project coordinate system. It has the topo surface information. It has the ground information. And now I'm going to use this site as the source file to align the rest of the consultant files. So let's save this file for one more time. And I'm ready to do the work for the other ones. Any question here before I move to the coordinates with the architecture? All right, so notice how the project origin is left ignored. We are actually not using this as part of the coordinate system. We're just going to use the survey point and the project base. Oh, one more thing before I move out. Make sure make sure that the elevation of the project north is set to the ground level. So that'll be 62, I think. And then I'm just to double check that my elevations are correct. So if I go to south, yeah, notice how these elevations are reporting elevations relative to the project north, project elevation. And so when you switch to an elevation, you can always change this to report survey points. And so the ground level needs to be 62. Again, switch to an elevation, select the levels, edit the type, and switch the elevation base to survey points. and that way you have overall elevation. And this should be aligned with your path. Okay, so this is what we should have in this site. Let's save it. And close it. Because now we're going to use, this is a source file. This source file is going to be packed and sent over to the consultants. And each of the consultants is going to use it as a way to import the shared coordinate system. And then the triangle point, the survey point that you see in every building is going to be exactly the same thing. So now I'm going to close this file. And let's start with the architecture one. So the designer or you as a consultant receive this model and you're asked to establish shared coordinates. So I'm going to open the file in the data set called library link architecture. This is a small library in 3D. This is how it looks like. But level 1 displays the survey point and the project base point in a completely random location. So if I actually link my CAD file, they're not going to be in the correct elevation nor in the right coordinates. But we're going to fix that. So looking at the process, this is the process that I want you to remember. And this is going to be in the test next Thursday. The steps is that identify the project that determine the shared coordinate system. We did that already. We just finished that file. Then we're going to link this source file. And the source files will be aligned, rotated, and moved. You never move your Revit elements. Your Revit elements remain in place. You never move them because then you're going to start breaking the system pin relationship of storefronts and the constraints. Remember all the constraints that we talk about it. When you grab those and move them to another location, then those elements start failing. So it's never a good idea to move your Revit project. What we move is the link. And then the final step is to acquire the shared coordinate system. That is the process. All right, let's do that. So under the Insert tab, let's link the site model. So Manage tab. And under the Manage Links, the Revit folder, add the my file, which, yeah, my file is the site. This is the site I created. The site I just saved. And the positioning, this is the first time I'm doing it. It doesn't matter. You can do center to center. That's okay. Center to center is fine. And then hit open. Wait, is this the site I saved? Because this has a 518 and I just finished that. Let me just double check. I save this. The site coordinates under rack. So manage links, add site coordinates. This is site coordinates. This is the file I just saved. And hit OK. Now when I switch this on 3D and zoom extent, these are in completely different places, right? My site is in a different place. My architectural file is in a different place. But I need to do a one-time alignment and then establish the shared coordinates. And so the easy way, the first thing I'm going to do is align it in an elevation. So in the south elevation, I'm going to move the link. Remember, I always move the link. I never move the Revit geometry. So I select the link and I move it to snap it to the ground level. The ground level is my anchor. And notice also these elevations are totally incorrect. The architect sure doesn't have the shared coordinates. Then I'm going to switch to a floor plan elevation, a floor plan. Maybe I need, no, to the site plan. And notice how this is the gap. And then I'm going to move the link from the project base point location to the intersection of 1 and A. And when I switch to a 3D view, here it is. This is the project correctly placed. So that was step number 3, right? In my list of things, I am at step number 3. And now step number 4 is to acquire the shared coordinates. The last step is to select the link file. And you're going to notice that one of the instance properties of the link file is this thing called share site. And a share site, it's a one-time operation in the life cycle of a project. So I'm going to acquire the shared coordinates. So this is the equivalent of grabbing the location of the project base point and make it yours. So in the 3D view, I'm going to switch under the site category, I'm going to switch on the project base point and the survey point. Notice the location of my points. And then this project base point in gray is the location of the survey point in the link file. This is the location of the survey point in my architectural model. And so to make them align, select the project, the link file, enable the share site, and acquire the shared coordinates. And what that's going to do is going to move your shared coordinate system to the link shared coordinate system. All right, so I'm going to acquire and then reconcile. And notice what happened. Immediately, the 2 points are on top of each other. And what's happening now is that these 2 files are always going to try to maintain a line relationship. And when you select this model, you're going to see it has a share site called internal, and that is the share point between all the models that needs to be coordinated. So notice the project base point doesn't get affected at all. So the project base point is discipline specific because different disciplines may have different start points. Think about the rooftop mechanical may have a different start point than the structural. And so but in this case, I just want to keep exactly in the same location. So in the site plan, I'm going to select the project base point and move it to the intersection of A and 1, snap intersection. And the other thing, remember how my elevations were wrong? Now that I established the shared coordinates, the elevations are reported correct. And so that is one of the advantages of using shared coordinates, that all the elevations will be correctly coordinated. Okay, so we did this with the structural model, well, with the architectural model. Now we're going to do this with the structural and the MEP. So let's save this file. And in fact, check, you don't have to do this, but I'm just going to show you that if you decide to, let's say, detach this model. So I'm going to manage tab, manage links, and then the Revit model I will detach it. So remove it. My site model is not there anymore. Now, if I go back and reattach it, you go manage links, and I add it. Here is my site coordinates. All I need to do is to establish the shared coordinates, because this is going to remember the aligned location between these two models. So it doesn't matter that they are detached moving forward. You can link via shared coordinates, and the models are going to fall exactly in the same place. There you go. And so when you send incremental versions to your counterparts, you can replace the model, and as long as the shared coordinates are enabled, they're going to fall right in the same place. Okay, let's save this. And let's do the same alignment with the structural model. So I'm going to go a little faster because this is exactly the same process. So I'm going to close the architectural model, and I'm going to open the library link. The library link structural. Library link structural. There we go. This is the structural model, but this is what the structural model, the structural consultant is going to do on your end, on his end. You don't have to do this work for him. The BIM manager usually will write down this recipe and what is the proper method of aligning coordinates, and send them via email to the BIM managers of the counterparts in case there's any doubt. But notice how the project base point and the survey point of the structural is in another different location. But we're going to do exactly the same thing. On the site plan, we're going to link the source model. So insert, manage links, and then add the source model. It's this site coordinates. And because this is the first time we're doing it, we're going to do it center to center. And then hit OK. So again, they're in a different location, in a different place, in a different elevation. I switch to the south elevation and move the Z elevation first. So again, select the model, the link model, and move the ground elevation to the top of concrete. And maybe, this top of concrete is not usually the top finished floor. So if it's like half an inch below that, the structural engineer can do that as well. We're going to assume that the top of concrete is the same as the top of finished floor. Then I switch back to the site plan and move the link. We're going to move it from the project base point location to the intersection of 1 and A. SI to snap intersection. And now I have, now that I have the site in place, let's double check it in 3D. Yeah, that is the structural model. It looks correct, visually looks correct. And now I can enable shared coordinates. Same thing on the, I'm going to do this now on the site plan. Notice in gray color, I have the location of the, this is the shared coordinate system from the model. To establish coordinates, select the site model, establish share site, acquire the shared coordinates, reconcile. And notice how now the 2 points are exactly in the same location. And now I'm going to fix the project base point and move it into the intersection of A and 1, SI again. Again, this is something the structural engineer will do to align the model. And now we save it. And repeat the process for the MEP. Now, any question here so far? If you have time, I mean, this will be a homework. Do this for the MEP model. It's exactly the same process. We open the MEP model, we link the file, then we rotate, change the elevation of the link file, and then we establish our coordinates. Let's verify that everything falls in place in the site model. So I'm going to save this file, and I'm going to close everything. Now, to verify that everything is working, I'm just going to open the site coordinate model, and I'm going to link the architectural and the structural model using shared coordinates, and everything should be falling in place right in the same location. This is the site model, and remember the site model established a relationship with the architectural model and the structural model already. Shared coordinates are already established. So when I go to insert, manage links, I add the architectural model, and in the positioning, I don't have to align again. All I need to do is insert the model using shared coordinates. And hit OK. And the model is right in place. Exactly in the right place. And I'll do the same with the structural. So manage links, Revit file, add, and then we select the structural model by shared coordinates. Hit OK. And the structural model is right there, exactly in the same location. So we started with a system of 3 models with 3 different coordinate systems. And but we apply a method of shared coordinates between the 3 of them. And moving forward, these shared coordinates will be in place. All you need to do is to respect the location of the link files. As a matter of good practice, every link should be pinned. So I'm going to pin the architectural model. I'm going to tab select. I'm going to try to select the, I'm going to hide in view this element. I'll select the structural model. I'm also going to pin it. And then I'm going to retrieve the hidden object again. Oh. I should use visibility graphics instead. Revit links. I have the architectural. Select the structural and pin it. And go back to visibility graphics and make the architectural visible. And now the shared coordinates are in place. Ahmed has a problem. I cannot select or move the link model, need an elevation, side views. Okay, okay. You remember what this button is about? You probably had this button enabled. So when, oh, or this one. If you have disabled the ability to select and modify link files, make sure this is disabled. Otherwise, you won't be able to. Look, I enabled this, and now I try to select a link file, and I can't. Yeah, and the purpose, I think we have to disable, we have to enable our ability to select link files, and then we need to re-enable it so that we don't move them by mistake. So let me show you a tip. So in the event that you move a file, in the event you move a file, you will be presented with this. This is a very old thing. This is from Revit 2011. But the message is exactly the same. If you move a model, you will be presented with this warning. And it says, the share site between the links have been modified, but not saved back to the link file. Upon reopening, the link instances of the link model will return to the last saved position. You can save the link file model later via the manage link dialog. This warning, it's actually about, it's a really serious warning. What this is saying is that Revit has detected a shift between the two models, and it's presenting you with a solution. It says, if you save the current shared coordinates, then it's going to modify the link counterpart. And this is bad because you don't want to modify your counterpart's model. So if you see this message pop up, always hit cancel. If you hit OK, you're basically ignoring it, but you will be presented with this dialog box later on. So every time you receive, if you see this message pop up, always hit cancel. So let's see how that happens. So I have the architectural model here in the right location. And I'm modeling really fast, and then suddenly I do this. I just grab the model, and then I'm presented with this dialog box. And your first instinct is to click the button that says Save Now. And in my opinion, this is not this button should be renamed. Like Save Now means you're going to publish the shared coordinates into the link, modifying the link. And so when you're presented with the dialog box, always hit cancel. And when you hit cancel, it's going to return the model to the original location. But a lot of us think that saving is a good thing. So your first instinct is, oh, I need to save it. No, no, no. For this dialog box, don't save. Actually hit cancel. And that's going to return the model back to the original location. And so to avoid this from happening, select the model and pin it so you don't move it by mistake. And you can also disable your ability to select links so that you can even select it. You won't be able to snap to it. It's just there as a floating thing, which is what Ahmed was experiencing. All right. That is the typical process of establishing shared coordinates. I added the extra topic of topography using existing elevations from contours. One thing you may notice here is, for example, that the site, it's like encroaching, it's like overlapping the facade of these elements. And if we want to modify that, then we need to start getting into the business of grading. And grading, it's a very manual process in Revit. It involves, edit the surface and start adding points with different elevations. So, for example, if I know that this elevation needs to be 62 at the bottom of these sills, then I need to add points at an elevation, an absolute elevation of 62. And you see how the sides start like moving down. This is totally manual process. And then I end up with a site that is sort of graded, not my favorite graded, but I'm not a landscape architect. So again, when it comes to showing the site, architect scope is just to show something that connects with the site, but it's not our job to document the final grading elevation. So we usually just portray something that it's like a design intent, and we leave that to the civil to display the final grades. All right. Any question? All right. You can practice this with the mechanical drawing. There is a mechanical drawing here. You can do this as a homework. Establish your coordinates with the mechanical file, which is under the data sets as well. And it's the same process. Here's the MEP. Open the MEP, link the site, move a line, rotate the link, establish your coordinates, save it, and then moving forward, you can just use share coordinates. All right, so I'm giving you the answers for next week's test. I'm going to ask you where are the 3 points in Revit? I want to ask you what is the point that give us share coordinates? That is the survey point. The point that gives us a rotation is the project base point. You can see that the rotation is embedded in the project base point. The maximum size of the project is 20 miles. And then if the internal origin can be editable, is that true or false? It's false, right? The internal origin cannot be edited. It's the center of the 20-mile space. You can see it, but you cannot select it. You cannot move it. You cannot snap it to it. All right. Any question? It's 7:15. I think I can close now. There is an advanced thing about shared sites that involve multi-building. A site, it's a different coordinate system that it's associated with different buildings. I'm not going to go over that unless you strongly want to, but you have the ability to duplicate sites and snap it to different building corners and create new building coordinate systems. And when it comes to multi-buildings, like you're doing a university or a big medical campus, then it's useful for facility managers to control what is the insertion point of each of those buildings. And you can do that using multiple sites. But I'm not going to go over that in this class. All right, any question? Is this helpful? All right, save this file. Then I'm going to stop the broadcast. And if you want to stay over and want me to review or look overhead when you're done, feel free to stay over. Otherwise, I'll see you Thursday. All right. Have a great evening.
Thank you.
Good night.
you.
Thank
Bye.
you.
Good night.